so in section 6.4, we're talking about compound inequalities, and they are joined by the two words either and or, just like in English class you have compound sentences that have ands and ors. We also have compound inequalities. And what we're going to do with these is we're going to graph them on a number line a lot of the times. And let's see if we remember from yesterday. If I had the symbols a less than and a greater than, do I have an open circle or a closed circle? Open. And if I have less than or equal to or greater than or equal to, I have what kind of circles? Closed circles on our number lines. Okay, so if it's or equal to, it gets included with the solutions. If it doesn't say or equal to, it is not included with the solutions. It's just a boundary marker. So all we're doing on these two problems right here is we're graphing the scenario on a number line. So let's just do the first one. A says all real numbers. That means I'm going to show those numbers on a number line that are less than 0 or greater than or equal to 2. Okay, so we're going to take them one at a time. My two numbers they told me were what? 0 and 2. So make sure your number line is big enough to hold both of those numbers. I just did -1, 0, 1, 2, 3. Okay, so just make sure your number line is big enough to cover your two numbers. And it says, okay, so what you're going to do is you're basically going to take two inequalities and put them on the same number line. Okay, so if I want to show the numbers that are less than 0, I go to 0, and do I put an open circle or a closed circle at 0? It just says less than, right? So not or equal to. So 0 gets an open circle. And which way do I shade for less than 0? Left. Okay. So we're just putting two inequalities on the same number line. And then it says or greater than or equal to 2. Greater than or equal to 2. So do you think 2 is going to get an open circle or a closed circle? Closed, because it says or equal to, so 2 is included. And which way do I shade my number line to show numbers that are greater than 2? To the right. Now, what do you notice about how they're shaded? What do you notice about them? Which way are the arrows going? Opposite directions, okay? Every time there is an or inequality, that's going to happen. So write yourself a little note of that. Or shades opposite. O for O. I'll put directions, make it complete. Or shades in opposite directions. So every or inequality we're going to see today, they're going to shade in opposite directions. And I'm going to highlight that because it's important. So on a multiple choice test, if we have an or problem and there's answer choices that are not shaded in opposite directions, then we know that those are wrong, right? Or is always going to shade in opposite directions. There's very few exceptions with that, and we will not get into them in this course. All of our ors will shade opposite. Part B is a little different. It has an and in the middle, okay? So all real numbers that are greater than or equal to -5 and less than -1. So draw yourself a number line again. What are my two numbers they gave me? -5 and -1. So make sure you at least include those. Remember, negatives go backwards. All right, this time it says greater than or equal to -5. My bulb is going crazy. So greater than or equal to -5. So do you think -5 is going to have an open circle or a closed circle? Closed, because it said or equal to. And this one, where will we shade for greater than? To the right. I'm just put a little arrow here because I think I'm going to have to do something in a minute. And it says and less than -1. So does -1 get an open circle or a closed circle? And less than, where do I shade? Left. So these are going to be shading toward each other, right? Right? So every and we're going to do is going to shade in the middle. So an and inequality, the solutions are between those two numbers. Okay? So remember what I said on a number line, all the solutions are darkened. If it's darkened, it's a solution. Okay? So on this one right here, is -10 a solution? No. Is -3 a solution? Yes. Is -5 a solution? Yes. What about -1? No. What about -1.5? They're right there. Yeah. Okay? So everything that's darkened on a number line is going to be part of your solution. And that's just how we graph them. So any questions about how we graph them? Okay, so we said or shades opposite and shades together. That would be like me saying, Jasper and Joey, come help me move this table. They would be sharing the workload of moving the table with me, right? Right? And they share it. Or means they go in opposite directions and they share it. It's a shared job. So what we're going to do is we're going to actually work inequalities that are compound inequalities. Now, compound means 2 and 1. 2 and 1. And this is what and inequalities look like right here. Notice I have 2 less than signs. Right? Where's the variable at? It's in between them. Right? So x is what the solutions are. So the solutions are between the 2 outside numbers plus the +5 in the middle. We'll fix that in a minute. Okay? So this says the solutions are between 2 numbers. So this is an and. So all ands are set up like this. Something else you need to know about ands. You can only have a less than or less than or equal to. So all your symbols have to be pointing left. And also the end numbers, the numbers on the outside, need to go least to greatest. So the lower one needs to be on the left, the higher one needs to be on the right. And if it's not that way when we get the answer, we can fix it back that way by reversing everything. So let's just try working these problems. They're really easy and they're really quick. You're just doing 2 problems at the same time. We're not going to split them up. There's some teachers that would advise you to split it up into 2 separate problems, but I found that it's easier just to show kids how to work it like it is. So what you want to do, x is not by itself in the middle, is it? No, it's got a +5 in there. So if I want to get rid of a +5, how do you think I'm going to get rid of it? Subtract it. But this time we're going to subtract it in 3 places. I'm going to subtract it out of the middle to cancel it out on both sides of the inequality. Okay? So the only thing different, basically, when you're getting your middle x by itself, you got to do it in 3 places, not just 2. And then you work it out. What is 2 minus 5? -3. It's less than x. And then copy the less than. What's 9 minus 5? 4. So our solutions are between -3 and 4. You do need to graph these on a number line. These are kind of spaced out. So draw yourself a number line. How do we shade an and? Where do and shade? Opposite or together? Together. They shade in the middle. So are these circles going to be open or closed circles? Open. So you just go to -3 and put an open circle. You go to +4 and put an open circle. And you know this is an and. So and shade in the middle. There you go. Any questions? So basically, when you graph it, you just circle your two endpoints, look to see if they need to be open or closed circles, and if it's an and, you shade together. And ands are always written that way, so that's how you can know they're ands. There's another way, and I'll show you that way in a little bit, where you can always know it's an and. Copy down D. D's got a little bit more going on in the middle. So what you do is you just figure out how to clear everything away from the x. So what do you think we're going to do first to get the x by itself in problem D? Subtract 4 to start with. Very good. So those cancel. What is 10 minus 4? Is less than or equal to 2x is less than 20, right? And then how do we get x by itself? Divide everything by 2. Now, y'all, if you're dividing by a negative number, we would have to flip our inequalities, okay? But since we're not, we're not. So what is 6 divided by 2? Is less than or equal to x is less than, what's 20 divided by 2? 10. So any questions on our solution? All right, we're going to slap those on a number line. Got to go from 3 to 10 at least. I cannot evenly space my numbers out for anything. All right, does 3 get an open circle or a closed circle? Closed, because that one says or equal to. So you color that one in. What about 10? Open or closed for 10? Open. And where do I shade an and? Where do I shade it? In the middle. So all my solutions are the part that's darkened. Is this terrible? Is it okay? Let's do one more, and then we're going to do ors. All right, so how do you think we're going to get x in the middle by itself this time? What are we going to do first? Subtract 3. Very good. So what is 11 minus 3? 8 is less than negative 2x. Less than or equal to, what's 19 minus 3? 16. Then what do we have to do to everything? Divide everything by negative 2. And since I'm dividing everything by a negative, I have to do what? Flip my symbols. Just make sure you keep the or equal to part where it is. And what is 8 divided by negative 2? Negative 4. X is in the middle. What is 16 divided by negative 2? Negative 8. Now, what did I tell y'all about ands when we started on? They had to be less thans. And what else? What about the numbers? They got to go least to greatest. These are greater thans and greater than or equal to, right? And my numbers are greatest to least, right? Negative 4 is bigger than negative 8. So when that's the case, all you do is swap everything around. So you're going to have negative 8. And it had the or equal to, so bring that to it and swap it to less than. Change this to less than 4. So at the very end, swap everything around. If you're not in least to greatest and you're not in less thans. All right, now we can draw that number line. Negative 9, negative 8, negative 7, negative 6, negative 5, negative 4. I'll stick a negative 3 on there. So just make sure your number line is big enough to take care of those two numbers. If they're like really far apart, then go by 2s or go by 5s or something like that. All right, so does -8 get a closed circle or open circle? Closed. What about -4? Open. And where do I shade? In the middle. They shade toward each other. And means together. So any questions about and inequalities? So I did the ands first, so the ors would look really simple. And they are. First of all, you need to recognize an or because it's going to say the word or. Or will always say or. If it doesn't say or, it's an and. Okay? Ors have to say or. So they will, and what they are is basically two separate problems with the word or in it. So it looks like you're just doing two completely separate problems, and you are. Okay? So two totally different problems with the word or between. So they have to say or in the problem, and we're going to say or in our answer. So when you have an or, all you do is just solve both equations, both inequalities. So I'm going to solve 2x plus 3 is less than 9. And then I'm going to solve 3x minus 6 is greater than 12. And then between those two answers, I'm going to write the word or, and then I'm going to graph my number line. So it's basically like you're working two separate problems, and you're just going to put the answers together. Okay? So how do we solve 2x plus 3 is less than 9? Subtract 3. So 2x is less than 6. And then what do? Divide by 2. X is less than 3. And so I don't forget, I'm going to go ahead and put an or right here. Because you have to have the word or in your answer. And then we've got 3x minus 6 is greater than 12. How do we get x by itself? Add 6. So 3x is greater than, what's 12 plus 6? 18. Divide by 3. X is greater than what? 6. Now there's our solutions. So what do y'all remember about the number line for ors? They shade in opposite directions. So you just draw your number line. We'll do it over here. That's crooked. Make sure you include those numbers. So 2, 3, 4, 5, 6, 7. 3 gets an open circle, and it says less than 3, so that one shades left. 6 gets an open circle, and it says greater than, so that one shades right. And they're shaded in opposite directions. Any questions? Okay. You try these two. One's an and, one's an or, and graph them on a number line. You get both of them done. Go ahead and check them with a neighbor. Check your number lines as well. All right. So is number one an and or an or? How do you know? It says or. How do you solve an or? How do we solve it? Do I do anything fancy? No, I just solved both of them, right? So the first one I'm going to subtract 1, and I get 4x is less than or equal to negative 4, and I divide by 4. And I get x is less than or equal to negative 1. Did y'all get that one for the first one? I'm going to go ahead and put or. Y'all make sure you wrote the word or with your answer, because if you did not, it is wrong. I will count off for that. Or have to say or in the problem and or in the answer. What's 17 plus 3? By 5. X is greater than what? 4. Y'all get those? And then when you graph them, negative 1. 2, 4, 5. Which way do we shade oars? Opposite direction. So negative 1 gets a closed circle. I shade left. And 4 has an open circle and it shades right. Now sometimes, y'all, when you get these, it might be in the other direction where the bigger one's over here and the lesser one's over here. But when you graph them on the number line, the number lines will still come out to be opposite directions. Does that make sense? So even if they're not opposite directions right here, when you graph them, they should be. Does that make sense? All right, so number one's an and, so what's number, I lied. Number one's an or, so number two's a what? An and. How do you know number two's an and? It doesn't say or. An or's have to say or, okay? Another way is because and shades in the middle, and it has x being in between two things. So how do I solve an and? Yeah, you want to get the x in the middle completely by itself in the middle. So subtract 4. What's negative 12 minus 4? Is less than or equal to negative 2x. Is less than or equal to what? And then what did you do? And what did you do when you divided by a negative? Flipped all my symbols to greater than or equal to. And what's negative 16 divided by negative 2? And what's negative 8 divided by negative 2? Can I leave my answer like this? No, I have to do what? Flip everything, right? 4 on the left, 8 on the right. This one had an or equal to. This one had an or equal to. So that's correct, right? Everything less than and numbers are least to greatest. Where do we shade hands? 3, 4, 5, 6, 7, 8, 9. Does 4 get an open circle or a closed circle? What about 8? And I shade in the middle. So raise your hand if you got that one right. Any questions? Good job. All right, that is all for compound inequalities. Next, we're going to do section 6.5, which is absolute value equations. Now, this is the weird little stepchild of this chapter because it's the only section in this chapter that has what symbols? Equal signs. Everything else in this chapter is inequalities. So this one's just kind of like a little detour for a second. We're actually doing equations for this section. Now we're doing equations because on Thursday, we're going to do absolute value inequalities. So we're doing absolute value equations today. And on Thursday, if my plan goes the way it's supposed to, then we will have absolute value inequalities. And it will kind of put today's lesson, both of today's sections together in one thing. So let's just talk about absolute value for a second. Do y'all know what it is? What it means? What does it mean? What kind of value? Positive. Is the absolute value always going to be positive? Yes. Do you know why? So y'all have been told before that absolute value is always going to be a positive number, right? You're right. You know why? Nobody knows why? Do you know what the definition of absolute value is? Absolute value is the distance a number is from zero. Okay? So think about a number line. If I have the number 5, how many spaces away from 0 is the number 5? 5. If I have negative 5, how many spaces away from the number 0 is the number negative 5? It's 5 spaces. It's not negative 5 spaces. Right? Right? So if I take my car and I drive to Walmart, okay, and I get there in 8 miles, which is pretty much how far it takes for me, okay, and it takes me 8 miles to get to Walmart, and then I come home and go the exact same path that I took before. Did I go a negative number of miles just because I went backwards in the other direction? No, I went how many total miles then? 16, right? So it kept adding a positive number. Okay, so absolute value is a distance a number is from 0. That's why it cannot be negative, because distances are not negative, no matter which direction you go. All right? So absolute value is always going to be positive because it's always a distance it is from 0. So this is the absolute value of some number equals 7. How many numbers have an absolute value of 7? 2 numbers actually have an absolute value of 7. What 2 numbers have a distance of 7 from a 0 on a number line? Yeah, so on this one, you just write x equals 7 and x equals negative 7. Because both of those numbers have an absolute value of 7. So what we have to do when we're solving absolute value equations is we have to consider inside the absolute value bars, it could be a positive or it could be a negative, right? Because when I take it out of the bars, it's going to be a positive, right? So all of these numbers right here on the outside of the bars, where it's after the equals, are all going to be positive. If it's a negative out there, then it's mathematically incorrect. It's not possible to solve it because the absolute value should always equal a positive. Okay? So when we solve these more complicated things, like for instance problem B, the absolute value of x minus 3 equals 8, well, x minus 3 could equal positive 8, or x minus 3 could equal negative 8. Right? The inside of this could be positive 8, and the inside of this could equal negative 8. Because the absolute value of positive 8 is 8, and the absolute value of negative 8 is 8. Okay? So when we set this up, we set it equal to the positive and the negative value. And then you just solve them both. How do we solve x plus 3 equals 8? Add 3. X equals 11. And then x minus 3 equals negative 8. We add 3 again. X equals what? Negative 5. And we can check them. What's 11 minus 3? 8. The absolute value of 8 equals positive 8, doesn't it? And then negative 5 minus 3 equals negative 8, right? And the absolute value of negative 8 equals positive 8. Hang on a second. I had somebody. All right, so the next one. The absolute value of 2x plus 3 equals 15. That means that the inside could equal what two numbers? 15 or negative 15. So we say 2x plus 3 could equal 15, and 2x plus 3 equals negative 15. Now, I don't care if you do the negative first and then the positive or vice versa. You just got to do it one for a negative, one for a positive. So how do I solve for x? Subtract 3. So 2x equals 12. And then divide by 2. And x equals what? 6. Check the other side. And y'all are going to do the same mathematical operations. You're just going to have something different over on the left. What's negative 15 minus 3? Divide by 2. X equals what? Negative 9. So x could equal 6, or x could equal negative 9 to make the absolute value equal to 15. Does this make sense to everybody? Now, D is a little bit troublesome. What's different about this D here? The absolute value bars are not by themselves yet, are they? Okay? So what you have to do when the bars are not by themselves is you're going to have to treat this whole absolute value part like it's a variable and get everything away from the bars. Right? So you want just the absolute value part on the side of the equal sign by itself. So how do you think we're going to move that minus 5? Add 5. So then I have 3 times the absolute value of 2x minus 7 equals 9. Now what do you think we could do? Not subtract 3. It's 3 times it, so we can divide both sides by 3. So absolute value of 2x minus 7 equals, what is 9 divided by 3? 3. All right. And now when you have the bars by themselves, then you can split it into two problems. Okay, so get the bars by itself, then you can split into two problems. So we're going to say 2x minus 7 equals 3. It could equal negative 3. And I add 7. 2x equals 10. Divide by 2. X equals 5. Add 7. 2x equals 4. Divide by 2. X equals 2. So those are my solutions. So those are really as difficult as they get when you have to get the bars by themselves first and then split it up. So any questions about that? All right, I want y'all to try this one. And yes, I had it covered up on purpose. Get the bars by themselves and then solve it for M. You should get 2 answers. You get finished and check your 2 answers with a neighbor. All right, what did you have to do first on this problem? Yeah, we want to get the absolute value bars by themselves, so we do what? Add 5 to start with, so that gives us 4 times the absolute value of m plus 9 equals what? Oh, I am frozen. Thank you. I was seeing how far we were to the end, and we're very close. So 19 plus 5 is what? 24. And then what do? Divide by 4 to get your bars by themselves. So the absolute value of m plus 9 equals what? 6. So then we have to consider m plus 9 could equal what 2 things? Yeah, m plus 9 could equal 6, or m plus 9 could equal negative 6. So what do I have to do to get the m's by themselves? Subtract the 9. What is 6 minus 9? Negative 3. And then I subtract 9 over here, and m equals what? So m could be negative 3 or negative 15. Raise your hand if you got those two. Any questions? All right. So the next little thing says, solve the absolute value equation if possible. If possible. So if they say solve it if possible, that means you try to solve it like it is possible, right? So anytime something says if possible, that means you try it and see if it works or it doesn't work. So first we need to do what with this problem? Get the bars by themselves, so we would subtract 6. And we get the absolute value of 3x plus 5 equals what? Negative 8. Now, y'all, can the absolute value of anything equal a negative? No. So if you get the bars by itself and you have it equal to a negative, you say it's not possible. Because there's no possible way the absolute value of something can be a negative, because absolute value is a distance. A number is from 0 to a number line. We can't have a negative distance. There's no such thing as a negative distance. All right? Got it? Got it? So that's what that means. If you get the bars by themselves and it equals a negative, then it's not possible, and you can stop and write not possible and go to the next problem. Sound good? All right, here's your practice. On the inequalities, you need to draw the number lines. I know I've let you skip those yesterday, but today we need to draw them for compound. And then that 3 through 17 is absolute value equations. And what do we have tomorrow? Quiz. Sections 6.1 to 6.5. So everything we did yesterday and what we did today. We are going to review before we take the quiz. We've had a lot of people that's been out and stuff, so it will be beneficial